All right, so today we're going to keep talking about limits. We're going to focus on limits that revolve around infinity. So I want you to take a look at a graph real quick here that should be familiar to you. So can anybody tell me what that's the graph of? What of your basic functions that you guys studied in pre-calc is that one? That's the reciprocal. Yep. So, and there are some limits that we can calculate. So, namely, as x approaches infinity and as x approaches negative infinity. So for this particular function, what is the limit as x approaches infinity? So as x gets very, very large, what's happening to y? It's not. It's getting smaller, right? So as we go out, what is it getting closer to? To 0, right? Okay, and then for negative infinity, just trace it to the left. As x continues to get very, very negative, what y value are we getting closer to? 0 as well, okay? So we have that kind of limits involving infinity, okay, where it's x is the infinity piece of it. We also have limits going the other way. So in this case, limit as x approaches 0 from the right, and the limit as x approaches 0 from the left. And these are ones we looked at in the last section. So looking at that graph, what is the limit as x approaches 0 from the right? Infinity. And from the left? Negative infinity. Okay. So these kind of limits involving infinity describe horizontal asymptotes. Okay? Does that make sense? You see the graph where the horizontal asymptote is? It's right here. Okay? So horizontal asymptotes are limits as x approaches infinity, negative infinity. That's what you're looking for those. These kinds of limits around infinity describe vertical asymptotes. So we have this vertical asymptote up and down in the middle of this thing, and this describes the behavior of the function around that vertical asymptote, on the left side of it and on the right side of it. Okay? So these are the kinds of limits that we're going to talk about today. Okay? The horizontal asymptote ones and the vertical asymptote ones. So do a little definition while we're talking about it here. So the line y equals b is a horizontal asymptote of the graph of f of x if the following is true. The limit as x approaches infinity of f of x equals b, or the limit as x approaches negative infinity of f of x equals b. So kind of like we just showed in this first graph here, is that because the limit as x approached infinity came out to a number, 0, and also the limit as x approached negative infinity came out to some number, again, 0, then we knew we had a horizontal asymptote there. Now I want to caution you just a little bit here, though. Notice how the definition uses the word or, not the word and, in between, right? In the example that we did at the beginning here, both limits happen to come out to the same thing. They both came out to 0. But that does not need to be the case to have a horizontal asymptote. You only have to have one happening. And in fact, you can have 2 horizontal asymptotes, one for each end. Okay? So you can have up to 2 horizontal asymptotes for a function, depending. one for as x goes to infinity and another one for as x goes to negative infinity. But, like in this case, they could end up being the same, and then you actually just have one. Okay? But that's the idea, though. That's what we're looking for. Does the limit as x goes to infinity or the limit as x goes to negative infinity come out to just some number? Okay? So let's graph some stuff and take a look at this. So we're going to be searching for horizontal asymptotes with this function. F of x equals the absolute value of x over x minus 1. Start with that. Okay, now this is something that you were very likely not able to do by hand, right? Don't know what that graph looks like. So we're going to use our calculator on this one to take a look. And when we look at the graph, I want to see if we can come up with, first of all, what is the limit as x goes to infinity? And what's the limit as x goes to negative infinity? And then, once you know those two answers, give me equations of any horizontal asymptotes that you see. Okay? So, we don't usually graph stuff with absolute values, so I'll try to kind of help you out with that. So if I want to put this into my calculator, I got to go into math, over to num, and it's the first one, ABS. Now my calculator is a little bit more old school, so it still keeps the ABS. Some of yours actually put the bars in there for you. In any event, we want the absolute value of x, then divided by x minus 1. Something like that. Alright, now my window is still -2 to 2. That might not be big enough. I'm going to go ahead and graph it and just take a look. But I might need to expand that out a little bit, especially if we're talking about limits as x goes to infinity and negative infinity. Sometimes you're going to want to make your window pretty large to be able to see what's going on. So, and yeah, it doesn't look like I've really got enough to go on there, so I'm going to move that out, make it a little bit bigger. Maybe go -10, 10. And then it's a little bit more obvious. Do you guys see the horizontal asymptotes a little bit better on that one? How that function is leveling off either way. So what do you suppose I could do on my calculator to try and make a guess, or make an educated guess at what the limits are as x goes to infinity and negative infinity? What can my calculator do that'll be helpful? There's a button down here that might be helpful if I want to see what the values are as I move along the function. Trace, yes. I want to trace it, see what's going on. Okay, so tracing it allows you to take a look at the x and y values as you move a cursor along the function, right? So let's check out negative infinity first here. So as I move out towards negative infinity, take a look at the numbers for y as I keep moving out. And if I keep tracing, it'll keep moving the window over. What do you suppose the limit is? Look at that y value. Where is it headed? What's the y value? Looks like it's getting closer and closer to -1. Yeah. And if you really wanted to be sure, you could make that window down to -1,000 or something and just keep tracing it. And yeah, it's going to keep approaching -1. So we've got one of our limits here then. We just, by kind of inspecting here, the limit as x goes to negative infinity of f of x equals -1. Just saw that. Alright, well, let me fix my window here again. So now let's take a look at what we believe this thing is doing as x approaches positive infinity then. So trace it again. And we'll move the cursor over to the other side here and take a look at that y value again. As I continue to move out, what do you suppose is happening to the value of y? It's getting closer and closer to 1, exactly. Okay? So we've got the other limit then. So the limit as x approaches infinity for this particular function is 1. Okay, so then my question was, what are the horizontal asymptotes of this function then? So what are they? Those are my two limits. Yes. I've got two horizontal asymptotes for this particular function, y equals 1 and y equals negative 1, because of those limits. Okay? Okay, so that's using graphs to help search for some limits, some horizontal asymptotes. Let's see. I guess, well, while we're looking at it, let's take a look at the vertical asymptote stuff too, because we've talked a bit about this in the past, and it'd be worth it to take a look, because I think you guys can just inspect it here and tell me. So, do you see on this graph any vertical asymptotes? At 1, right? Okay. So, these were our horizontal. So we also have an x equals 1 vertical with that function as well. Yeah. And there are a couple of limits involving infinity associated with that one as well. So this would be the limit as x approaches 1 from the right, and we can do the limit as x approaches 1 from the left. Okay, so again, here's the graph. So what is the limit as x approaches 1 from the right? Positive infinity, right. And what was the limit as x approached 1 from the left? Negative infinity. Okay. So vertical asymptotes, like we talked about up here, are going to have ones coming from the right and from the left that involve infinity as your answer then. Okay, so in that particular graph, we could pull that out too. So, all right. So the next one, I'm going to do a problem involving infinity here that's going to be similar to some that you did in your homework last time, where it's going to say, look at the graph to guess what the limit is and then confirm using the sandwich theorem. So we're going to pull that back out again. But there are a couple of limits I want you guys to jot down. One of these we've already talked about, and this one will keep coming up, so might as well just write it down here so we remember it again. So this one, limit as x approaches 0 of sine x over x equals 1. Another one that you're just going to have to memorize that we're going to use is a limit involving infinity and its cosine x over x. This particular limit is always equal to 0. Okay? I won't make you guys memorize a lot of limits, but these two I will. Okay, so notice the difference, because sometimes it's easy to get these two confused. Okay? The one you looked at before, sine x over x, it's as x goes to 0 and it equals 1. The cosine x over x is as x goes to infinity, and that one equals 0. Okay? So kind of keep those in the back of your mind. For this particular section, because we're talking about infinity, we're really focusing on this second one now. So we're not going to really see this one too much, but both of those are ones down the road we're going to need to know. So, okay.